Hello, class.
Hi.
Like I said in my instructional video, I'm Dr. Disu Akeem Babatunde. I'll be taking you on MTH102 for elementary mathematics. I'll be taking you that. Elementary mathematics is fundamental mathematics, especially for those that study science courses. And we deal with calculus. And calculus is of two parts. We have integral calculus, we have differential calculus. But today, we are going to learn what we call combination of functions. And this function is the most important aspect of mathematics because every equation, every expression are functions. Let's start today. We have combination of function. Two or more functions can be combined together to form what we call, to get what we call new functions. And function is denoted by F. Are you with me?
Yes.
Hello?
Hi.
Function is denoted by F. I'll be writing, for example, F of X. This, can you see what I'm writing?
Yes.
Olani. Okay. This denotes what we call function. This function of F of X, or we call it at point X of X. And I will say that if you have two functions can combine together to form new function. For example, we have sum of functions. And sum of function, we have, like the name implies, we have F of S plus G of S. This will give us a new function. We have a new function like F of S plus G of S. This is a function. Then, like what you have in your course material, can you see my slide? Can you see my slide?
Yes, but you're right.
Yeah, this. What do you say?
Your write-up is not clear. The function F of X, is that an X or an N?
Okay, I will try to do better. It's F, it's S, I said S. It's not an S, let me write properly. We have F of X, F of S plus G of S. And this gives us what calls sum of functions. Sum of functions. Is that taken? Sum of functions. And when two or more functions combine together to form a new function. For example, we can have, let's go back to what we have here. We have, for example, let's take example of this. Let's just say if.
Okay, the first letter inside the bracket is X.
Yes.
Right? Then S. Please mute yourself, please. Hello?
Okay.
Are you with me?
I'm with you.
Now, the first bracket, we have
yes.
X inside of it. The second bracket, what is inside of it? Is it N or same X?
Yes.
The same X?
Yes, continue.
Okay, I say F bracket x plus s bracket what? Is it n or the same x that you wrote like that?
G of s is still, look at it. We have, I'm coming. Let me clean. We have f of s plus g of s. These are two functions.
The other one is g of x.
Yes, g. Yeah, these are two functions.
Oh God. Okay.
Exactly.
We'll try to understand, but
a new function.
It's not giving us. The writing is hard to understand. The write-up is hard.
Let's move on.
Okay.
Okay. Oh yeah. Good. Can you see my slide?
No, I can't see another one. The only thing I'm seeing.
Can you see my slide?
No.
Can you see the slide?
No, no.
Your course materials?
No, I can't.
You can't see the slide. Are you sure? Wait, let me see. Can you see the course material slide now? Hello? Hello? Okay, let me continue. Hello? You can hear me?
Yes, we can hear you.
Can you see the slide, course material slide?
Yes.
Yes. We have f of s plus g of s. When we add this plus, we call it sum of functions. And we get a new functions. Then we have f of s minus g of s, give another functions. This one we have f of s times that dot product. G of s we call product of function, and then we have last one. We have what we call quotient of function. For example, let's solve this equation, or let's solve this equation 1. I'll write it on my board. Let me share my board. We have, we have.
I can see the area. Maybe you can use this one. It's better.
You can see. Yes.
I can the course material.
We have this. Okay. I want to walk through the course material.
Just be
I want to show you how we form combination of functions, how we form new function. That's what I want to show for you through the whiteboard. My whiteboard is coming up now.
No, your whiteboard is not clear.
And let me clean it.
Can we use the course material?
Can you see it?
Can we use the course material?
You can use the course material.
The whiteboard, yes. I can't see
use
your whiteboard. I don't understand your writing.
Okay.
Let's use course material.
No, just g of x plus f of x. I said we give us a new function. Can you see it now?
I can see it, but what you are saying in your mouth is not what is appearing.
Hello, someone else to. No, listen to what I'm saying and follow what I'm saying. I said this x. This x.
You see, this one is now, it doesn't look like that. This one look good.
This x. I said when they have function like this, combined together, we give a new function. And if you say let f of s is equal to 2x plus 1. Can you see it?
Yes.
Comma g g g of x is equal to x minus 1. Is that taken? Then, if you sum the two functions together, will give us a new function. Yeah, that's why we say combination of function. Then, if you have f of x, I'm solving now, plus g of x. And our f of x is 2x plus 1. Our g of x is x minus 1. Then you collect like times. X, 2x plus, this will go with this, plus x. We have minus plus 1 minus 1. You can see that 2x plus x will give us 3x. And plus 1 minus 1 is what? 0. That's the new function is what? 3x. Is that taken? Hello? Okay. Is that taken?
Yes.
It's taken. Then this, we call this one sum of functions. Are you taking? We call this one sum of functions. Let's consider another example. We want to then talk of difference of function. If we still use the same example for difference of functions. We still use the same example. That is, we have f of x is equal to 2x plus 1. G of x is equal to x minus 1. Then, to now have difference of function, that is, difference of function. I'm coming. Then, to now have difference of function, f of x minus g of x. Is that taken? This is called difference of function. It will give us another function. Then we say 2x plus 1 minus bracket x minus 1. Is that taken? And this will give you 2x plus 1 minus 1 times self will give us minus x. Minus times minus 1 will give us plus 1. Plus 1. And then we collect like times set 2x minus x. I'm coming. Minus x. That will be plus 1 plus 1. And this will give you what? 2x minus x is x.
X, yes.
1 plus 1 is what? 2.
2.
This will give us another function. You get it? This one give us another function. And that's why we call it what? It gives us new function. Difference of function give us new function. This we call it what? We call difference of functions. I'm coming. Give us difference of functions. Is that taken?
Yes.
We can also proceed. Is that taken? We can also proceed to what we call product of function. Let's consider product of function of it. Then let me clean this. Let's consider another one. Then this is called product of function. If you have f of s and g of s, these products, we can put them in bracket like this. This product means multiplication. You times two functions together. That is, we now say this will now give you 2 of 2x plus 1 bracket times x minus 1 bracket. Then we multiply out. 2x times s will give you x squared. Is that taken?
Yes.
Then 2 times minus will give you minus 2x. We've done that. We now 1 times z will give you plus x. Minus times plus times minus 1 will give you minus x. We now combine it together. That we now have 2x squared minus, this one give you minus x minus 1. This is another function we get by product. This is called product of functions. Is that taken?
Yes.
Yes. We can proceed to what we call quotient of function, which is called division. This is the same way we can achieve the product of function, but we have special function called composite of function. We have special function called composite function. And the special function are two. We are going to learn two. We have what we call composite function. Then we have what we call inverse functions. These are two special functions we have to learn. Let's back to our course material. Can you see your course material?
No.
Hello?
No.
Okay, let me stop sharing. Okay. We are now on your course material. Can you see it?
Yes.
Hello?
Yes.
You can see it. We are now on your course material. Then you see it is an example. The question is forming a composite function. Let s of s is equal to 2 minus 4s and g of s is equal to s squared plus 3. Find f of g of s. B, find g of s is different. And we have to know this process, how to solve it, how can we see it that is function. Let's go to our white marker, our whiteboard, and see what we mean by that. Okay, we are dealing with composite function now. Let's clean the inverse of function. Let's clean it. What we are solving is composite function. Please, can someone help us with the example given in your course material? Hello? I'm waiting. Okay. We have f of s equals what? 2x minus 4. 2 equal to s minus 4. Is that taken? Then
Yes.
we are given g d of x is equal to s squared plus 3. It's equal to s squared plus 3. Is that taken? Then, so now have f bracket g of x. This is where we want to solve. Then, here, this g of x will completely replace x. Are you getting me?
Yes.
We completely replace x. X. This x. This x. This one. Then we have f squared plus 3. Is that taken? Hello?
Yes.
We have this. We now have, we have, this will be 2. I'm coming. Normal, this will be 2x minus 4 for x, for f of x. But this, where we now have x, will be completely taken by, g, will be completely taken by g of x. I'm coming. Let me clean this. Let me try. Yes. Here we have 2s. This place will be completely taken by g of x like this. Then to now solve this further, we are now going to put entire value of d of x, which is x squared plus 3x. Then we now put it bracket x squared plus 3x minus 4. You can watch the video, instructional video. Will explain. I did the explanation. I'm just showing the working. This will now give you, multiply 2 times x squared. We give you 2x squared. I'm coming. We give you 2x squared. 2 times 3 will give you 6 minus 4. And this will give you 2x squared. 6 minus 4 will give us plus 2. That's the solution of the first one. I hope you can get what I'm saying. Hello? Okay. Let's consider the second example that we have. Let's consider the second, that's B part of it, which is D of f of x. And G, we have D as D squared, that is dx squared plus 3. But this one, this x will be replaced completely by f of s. Now with f of s all squared. That's it. And the function of f of s is 2x minus 1 all squared plus 3. All squared plus 3. Let me put my plus 3. Is that okay? Then you expand this. You know, some of you don't know how to expand. Let's try to expand together. We now have 2x minus 1 or bracket 2x minus 1 plus 3. We expand it. That we've done the expansion. Then we now multiply out. This will now give you what? 2x times 2x will give you 4x squared. 2x times minus 1 will give you minus 2x. 1 times minus 1 times 2x will give you minus 2x. Minus 1 times minus 1 will give you plus 1. You know, minus times minus is plus. Then we now have, if you now write out, you now have x squared minus 2x minus 2x will give us 4x plus 1. This solution. Is that taken? Hello? Hello? This is the solution for B part. I hope it's taken. Okay. Let's back to our course material. Maybe we can take more example before we move on to inverse of function. Let's back to our course material. You know, this is what we solve. This is what we solve. You get, this is what we solve. We solve it. Then we can, I want us to take more example on it before we proceed to what we call it. Before let's go into your maybe your exercise here. I want to get more example for us. Even okay, we can. Oh, this one is easy to do. It's easy to do. Okay, can you see this question 14? Can you see question 14? Hello?
Yes.
You people are not? Okay. Can you see question 14? We have given that f of s is equal to root s and g of s is equal to s squared minus 1. It says find the composite function. Let's just take a and b of it. Do you get it? And you supply me the question.
Yes.
Supply me the question. Let me go to whiteboard. Okay. We have, in the question, we have f of s is equal to root s. Is that taken? And g of s is equal to s squared plus 1. Am I correct?
Yes.
Hello? Then the question A is what? Find f of g of, is it 0?
No.
Emmanuel, is it 0?
I can't say it.
On your course material, is this 0?
I don't have course material here.
Not you can't. Why? You are listening to lecture and you said you don't have the course.
I didn't know that we have lecture today. Where I am, I don't have my course material.
Okay, maybe. Okay, it's what? It's f of g of 1. F of g of 1.
Okay.
F of g of 1. And this is like this. This is what we have to solve.
Okay.
Then to start with this, we have, when we have f of x is square root of x like this, then this set will now change to g of x. We now call it g of x. I'm coming, let me put it properly. This will now change to g of x. Then g of x is x squared plus 1. Is that taken?
Yes.
Is that taken? Then they now say g of x is what? 1. This will now give us square root of 1 squared plus 1. And 1 squared is what? 1 plus 1. Yes. And then we have a square root of 2. Is that taken?
Yes.
Let's move to the P part of it. Then let me clean the solution. Then B part of it is saying that g f of 0, g f of 0. This will give us, our g is what? S squared plus 1. Emmanuel?
Yes, I'm here.
And then what we need to do is to replace this s squared by f of what? X.
X.
Yes. In order to replace it, you now put it value of, you now put it the value of f of s. And value of f of s is what? Root x.
X.
Square root x. Like this. Is that it? Square root s, that's the value of f of s. Then we now say square root of s squared will give us what? X plus 1. We now say s of that value is what? 0. We now say s, where you have s, you replace it with what? 0 plus 1. And the answer will give us 1. Is that taken?
Yes.
Yes, thank you for being with me.
You're welcome.
Okay. I hope the sample is okay for us.
Yes, it is.
Let's move to what we call inverse of function. Please try to study to what the instructional video sends to you. And you have your link in your memo, in your, what we call it, in your link. You have the link. I've sent you the link of the instructional video. Okay. Then let's move on to inverse of function. Okay, inverse of function. Let's back to our work. What we call inverse is f raised to power 1. This is called inverse. And this inverse of function is clearly different from what we call reciprocal. Can someone tell me reciprocal? Reciprocal is 1 all over f of s. It's different. You can say inverse of function not equal to reciprocal of function. You have to have it. And not every function can, not every function we can call can have inverse. Not every function have inverse. For example, not every function have inverse. If you have this function f of x, I'm coming. F of s. Someone is making us there. Its inverse is f raised to the minus 1 f of s. This is inverse. Then, I said not every function have inverse. The function that may have inverse may be 1-to-1 function. We call those functions 1-to-1 function. 1-to-1 function always have inverse. For example, every member in domain will have what they equal to 3. Let's call this codomain. That this range, this will be 4. This will be 6. You know what I did? I square each one. You know 1 squared?
Yes.
1 square is 1, 2 square is 4, and 3 square is what? 9. This, let's say this is a function. This is a domain. This match like this. This match like this. This match like this. This is called 1-to-1 function because there is no number or element in domain that mark twice with codomain, that is range. Let's do this one clearly. If we represent it by our Cartesian, we can have it. This will be 1, let's say f of s. I'm coming. Let's say we have f of s. If you use this one, we have, you know, x will come before y. This what? X. This f of x. I'm coming. Let me make it clear. This will be f of x, or at times we call it y of x. It's the same thing. It's the same thing, just different name. It's the same thing. Yeah, this here in the 4 coordinates we have 1, 1, 2, 4. We can have 3, 9. Like this. This is 1-to-1 function. You know what we have here is the same thing with what we have here, but we represent it differently. We do our representation differently because every member of domain matched with exact 1 member of codomain. This function is 1-to-1 function. We can also see the function that are not 1-to-1 function. I said that not every function have inverse, but the function that must have inverse must only be 1-to-1 function. Is that taken?
Yes, sir.
Okay, let's consider the one that we can. I just want to show you the function that are not 1-to-1. If you have f of x is equal to, let's say 2, 4, 3, 9, the same time square, you now have minus 5, comma 25. We can also have 5, comma 25. This function is not one-to-one function because the minus 5 and 5 match to 25. That's why it's not one-to-one function. Let's say you want to have it like this diagram I have here, this one. Then we can draw it domain like this. We can have it like this. Domain like this. We have 4. We have 2. We have 3. We have minus 5. We have 5. Then let's see the codomain. This area is called codomain. We have 4. We have 3. We have 5. You can see this match like this. This match like this. This match. Okay, I made a mistake. This would be 9. 9. And let's clean this. This will be 25. Are you getting me? You can see that minus 5 and 5 match to 25. In this case, this is not one-to-one function. Only one-to-one function can have inverse. Is that taken? Only one-to-one function can have inverse. I hope somebody is with me. Okay. Let's now look at how we can solve inverse function. If you follow your instructional video, we have steps that you take to solve the inverse of function. We have steps. There are 4 steps that we must follow. Is in your instructional video. Let's clean this and let's solve the function inverse of function. Okay, let's see. We have f of s is equal to s plus 1. Or let's say 2s here to make it clear. The first step you have to take when you are solving the inverse function, when you are solving the problem of inverse function, the first step is to replace this. You replace this by y. That's y is equal to 2s plus 1. Is that taken? Then what you do again, you now interchange or swap. We call it swap. Swap s with y or y with s, vice versa. Then this one will be our s now. This place will be 2y. We swap. Look at your instructional video, you see there. You swap plus 1. Then the next step, you now solve. To solve this, you now make y the Sawyer formula. Y 2s my 2y. This will become like this, minus 1. Then you divide through by 2. Is that taken? Then y will now give you 2x all over x. I made mistake, sorry. We give you s over 2 minus 1 over 2. Then, we find inverse. Then we now replace this one back to, this one will now be f of this x. I hope you can see what I'm doing. Is equal to, oh, sorry. Is equal to, wow. I'm sorry, I'm coming. Let me clean this place. Then we now replace this y here by f of what? F raised to power minus 1. We replace it of s is equal to 2 is equal to s over 2 minus 1 over 2. This is the inverse of s. There are 4. First one, we have to replace the function by y, which we did here. Second function, we have to swap s with y. That's what we did. We replace here by x. We replace y here by x. We replace s here by y. Then, third step, we have to solve. We solve this equation by make s the y the surrogate formula and divide through by 2. That will give you 2 over 2, s over 2, 1 over 2. Then we now replace this one by f raised to power minus 1. That gives us this. This is called the inverse. This function here is inverse of this. Is that taken? And you can verify. There's a way to verify this. The way to verify this is that you see this will give f inverse of this. We say dots, or let me use the word bracket. Brackets f of s, it will give us x. If we can multiply the function with the inverse, if you get what we call it, if you get s, if you give us x as our answer, if you give us x as our answer, we call it that that function have what? Inverse. That's the way to verify it when you are solving problem consigned inverse. Is that taken? Hello? Ojo Taiwo, say something. Can you hear me? Hello? Okay. Let's see what we have. Let's try to solve what we have. Let's try to solve what we have. We can also have another way. We can say f of s is f inverse of s must give us x. That's the two ways we can check whether our solution is correct or wrong. This is how we verify. This is how we verify inverse of function. This is how we verify inverse of function. Let's try to put the two in place and see how we get x. Then let's clean up my whiteboard. Then we have function that is equal to 2s plus 1. The inverse of it is of s is s over 2 minus 1 over 2. Then to solve, the way to solve is similar way that we use to solve the composite function, which we did 2 examples on it. Let's see, we now have f bracket f minus f prime of x. Then I say we are verifying now. Then, you know, F is 2x plus 1. Then when we now have this x, we now put the value of what? F raised to power minus, that inverse of s. This will now give us 2 brackets x over 2 minus 1 over 2 plus 1. Then what we do, you multiply through by s. If you multiply 2 by s, 2 we cancel 2 here, we have x, and 2 we cancel 2 here, we have minus 1 plus 1. We can see that x plus 0, because minus 1 plus 1 is 0, will give us x. That shows that the inverse we have here, the inverse of x we have here is real inverse of this function of f here. This is the function. This is the inverse of that function, of the function. Are you with me? Hello?
Yes, I'm with you.
This inverse of it. Whenever you solve inverse, you can verify whether your solution is correct or not. Any question? Because tomorrow we are going to move to another level, which is called the limits of function. That's what we are going to do tomorrow. I will send the video to you before tomorrow. Any question here?
No.
Hello? If there's no question, watch instructional video and make sure that you attend the class activity there. You attend the class activity and submit.
Thank you very much.
If you don't know, like I was talking with someone, I don't know the person, maybe it's Emmanuel. There are 4 of us here. You have me, which I'm Akeem Disu. We have Ojo Taiwo. And then we have Emmanuel. And we have Oluwatoyin, Ola something. And I want each and everyone to unmute his or herself and say something concerning this topic that we treated today. Hello.
Hello, sir.
Okay. I can hear you. Who am I speaking with?
Okay, Emmanuel, sir.
Emmanuel. That means you are not the talking. You. Emmanuel, what? We have 2 Emmanuel here. We have Emmanuel David, and we have Emmanuel
Emmanuel David.
David, yeah, that's your one. That's why
Emmanuel
I hope you
David.
are really participated in this facilitation today. Yes, but you didn't talk throughout.
No, sir. Although I came late.
Okay.
I came late, so I didn't really get
tomorrow we are
calculations
going to have another. We are going to have another lecture, and I want everybody to bring his or his pen and paper and write down something, because mathematics is about solving. If you don't solve, you don't really get what you are saying, unless you solve before you can get what you are really saying. Thank you, Emmanuel, for participation. Then Ojo Taiwo.
Okay.
Ojo Taiwo is moving about. Please just omit yourself, not.
Hello, sir.
I say something. Yes.
Hello, sir. Good evening, sir.
I hope you really enjoyed today's class.
Yeah, I really enjoy it. Well done, sir. But you made you
But you
mentioned
don't put
something
anything
about.
down.
I did put something down. Hello.
Okay.
Hello, sir.
Then do you have any question for me?
Not really, but you mentioned something about video clips. So how are we going to get that one? And what time are we meeting tomorrow?
We are meeting 3 p.m. tomorrow.
Okay, sir.
Then the video clip is on the website. We have a website called the Learning Content Management. It's also sent to you by the email I sent to you today. I sent it to you today.
Okay.
I sent yesterday, today, and 2 days ago. If you check your mail
box,
you
okay.
see it there. Okay.
All right, sir.
Emmanuel Udochukwu. Emmanuel Udochukwu. Can I see you? Hello?
Hello,
Hello?
Yes,
I can't
sir,
see you now.
Emmanuel
Let me
David.
see you.
It's
Okay,
Emmanuel
what
David,
about
sir.
Emmanuel Udochukwu? Yes. Do you have a question for me?
Okay, I wanted to ask in
no
the class activity you said, where can we find it?
Where the class activities as is on the video sent to you to your mail, and you can also get it with content management system. We have it. If you get through your study center, the ICT personnel there, we teach you how you can operate within the content management learning system.
Okay, sir.
Okay. If there is no further question, can we call it a day? A beautiful day.
Right, sir. Thanks so much, sir.
But who is talking? The last person I said, thank you so much, sir. Hello?
Hello, sir.
Someone say thank you so much, sir. I don't know the person.
No, this is Ojo Taiwo.
Okay, Ojo Taiwo. Okay, thank you very much.
All right, thank you, sir, so much.
Okay, thank you. We meet tomorrow. Then, bye.
All right, sir.
Okay.